Hi, it's Dave again from vivax-metrotech Canada. I'm here with Jeremy. We're going to film another instructional video. We've done quite a few videos. If you've found us already, you know that on the YouTube channel for Vivax Canada, we've done a whole bunch of instructional videos on fault locating and sewer locating. Today we're going to talk about fiber locating, residential fiber anyway. So we managed to find the world's most crappy fiber PED installation. By the way, it's late August here in Canada. This is the typical weather we get up here, but we do okay. Anyway, come on and have a quick look at this thing, and we'll talk about some different options we've got for actually locating the fiber. First of all, we've got the fiber coming in from the street, coming into this small enclosure. This is one of the residential drops going off to a house nearby. First thing you notice, there's no trace wire on the residential service. There's no trace filament, nothing. But there is a trace wire coming up that's embedded in this cable that they pulled out. It goes into this little grounding block here. We didn't have any difference clipping directly to the wire isolating or clipping to the ground strap, so that's what we've chosen. In this case, we would have put a ground stake in the ground, but instead we found a couple of T-bars just out behind us here, so we just scraped some rust off that and did that. Less than an ideal circumstance, but it's fine. It's already in the ground. It's made of metal, and it gave us a great response. Typically, we recommend you locate fiber using 512 hertz or very low frequencies. It's just a more reliable signal in many cases. It doesn't light up other nearby utilities as much. And when you're tracing fiber, you really want to know you're on your fiber. So what we want to show you the difference between direct connection on the trace wire itself and using a signal clamp. Because honestly, that's fairly controversial. There's been lots of damages done where people have tried to locate fiber using a signal clamp. We just don't recommend it in most cases because the signal is so much less. We're going to actually show you that today. So in this case, we've clipped on the ground strap itself. We're using 512 hertz. Transmitter's putting out 15 milliamps of current at 512 hertz. In fact, if you have a look up the way, you'll see my receiver sitting way up the road there. We're going to go up to that and have a look and see what we've got for signal. So we've walked about 30, 40 feet, I guess, in the pedestal just to show you the differences. The receiver tells me at this point I'm in 512 hertz. I can move it back and forth. I've got a good clean field. My peak and null are pretty well right on top of each other. I've got 10, almost 11 milliamps of current. I'm putting out 15. I got 11 of it right here. So it's a good solid locate. Come on and have a look at the actual display. It's a solid. It's not jumping around. We're in 512 hertz. Our gain set at 93. It says it's 3 foot 9 inches deep, and it says 10.8 milliamps of current. We'll do a depth confirmation by just raising the receiver up about a foot. There it is there. We had 3 foot 8. Now we got 4 foot 8. So we have a good depth measurement, and our current measurement's nice and strong. So we know this is the line we want to be on. So now what we're going to do is go back to our transmitter and switch from direct connection, clipping, to clamping to show you what the difference is. Remember, we've got about 11 milliamps of current at 512 hertz. Now, we can't clamp using 512 hertz, so we'll switch to something closer to 8 kilohertz or maybe 33. So let's go back and see what we've got for comparison purposes. So I've plugged the clamp into my transmitter. I've clamped around the conductor itself. I'm going to switch to 8 kilohertz to see if that gives us a reasonable signal launch. Of course, you never know how much signal you're launching with a clamp until you actually start taking your readings themselves. I'm at level 1. I'll bump it up to level 2 just to see if that helps us. So level 2 output, clamped around the fiber optic cable with the little trace wire in there. Let's go and see what we got. So we've selected 8 kilohertz back at the pedestal. And my signal now at 8 kilohertz is terrible. It's all over the place. It's jumpy. It's not reliable in any way. I wouldn't put paint down based on this. So we're going to go back and change to 33, and then we're going to try 83 kilohertz. So we tried 33 kilohertz a minute ago to see if that would improve it. It didn't. The signal was jumpy all over the place. We then switched to 83 kilohertz, and now we're getting a reasonable signal. At least the signal's not jumpy all over the screen, but my current measurement's only 0.14 milliamps. So when we made a direct connection at 512, we had 12 milliamps of current to work with. Clamping around the same cable, which you might choose because it's simple, is giving us just nowhere near the signal we need to do locates on fiber optic cable. So clipping is definitely the better way to go here. All right, so we're about 650 feet from our transmitter. The fiber runs underneath me here, goes across the street and goes up a riser on the far side of the street. I've got lots and lots of signal here left. We're using 512 hertz direct connection. My signal is nice and clean. It's solid. It's not jumping around. I've got 8.9 milliamps of current. So back there I had 12. We've lost almost no signal at all. That's the beauty of the low frequencies. They just don't drop off as much as the higher frequencies do. My depth measurement here says it's 2'9". I raised it about a foot, and now it says 3'9". So we're getting good depth measurement, good current measurement, and it's being consistent all the way across. My peak and null is lined up beautifully. It's a nice, solid signal. So this is clearly something I'd put paint on top of with no hesitation. If we'd stayed with our clamp back there, we would have run out of signal several hundred feet back there. So it's clearly making direct connections using low frequencies on fiber gives you the best results. And we hope you've enjoyed this video and the other videos we made for you. If you can think of a video you'd like to see, let us know at VVAX Canada, and we'll see if we can put one together for you. Thanks very much, and we'll see you next time.